Well, the company got started by the founder, Dick Cook, and he worked for Goodyear Aerospace and General Dynamics and all these other places. And his wife had valley fever, so they moved to Flagstaff in the 70s. And he wanted to start a consulting. That's all he wanted to do is do consulting in the industry, mostly in aviation. But the companies like Harry Robertson has Robertson Aviation down in Phoenix. We make the fuel tanks for him, and Harry go way back. Stan is jargon. He used to own Simula Government Products. Now it's BAE. They all ran around with each other. So Dick would be a consultant for him. And on a bar napkin 40 years ago, somebody came up with a design for a 35-gallon tank, and Dick said, "I'll build the prototypes for you, but I don't want to go in production." Well, we've been building them ever since. Same thing with the seat cushions and stand. He helped build the first ones, and he made them until they were going to find somebody to do it, and we're still doing them. And from that point, it just started. He started a consulting company, ended up being a manufacturing company. He did not want to be in manufacturing. So his heart was in development, research. And so he stayed in Flagstaff basically, and then left us down here. We ran the company for him, we made the money, and then he did the research.
Well, my dad conceived the company. And when you're 14 years old and there's work to be done and you would like to have some spending money, well, it's a no-brainer. Work at home. But more than that, I fell in love with the job because essentially what I'm doing here, and I've thought about this a lot, what I'm doing is I'm wrapping myself a Christmas present that the next day I get to unwrap and see what it is. Pretty much all of our processes have to do with an overnight cure. But it's not until the next day that I actually get to see the part in all of its glory. And so yeah, if you can imagine that for 50 years of wrapping yourself a Christmas present and the next day you get to unwrap it, yeah, that's what it is.
What does Quintus do? We're a manufacturing company, and we kind of have different areas we work in. We do aerospace, and we do medical external fixation. We make fuel tanks for military helicopters from 35-gallon fuel cells to 800-gallon fuel cells, which are a 5-foot cube. Currently, we're making Apache fuel tanks for the Apache helicopters and the V-22 Osprey, the helicopter airplane. We're making tanks for those currently. We also make seat cushions for military aircraft, mostly for helicopters, 53 or 4 different variations. Then we do medical, carbon fiber. We do what they call external fixation devices. If you've ever seen somebody with a rod and some screws going in, or they have rings, carbon rings that go around with the screws or the rods going through, we make those for the major medical companies in the United States and in fact all over the world. I started 29 years ago in Flagstaff. We had we call it the Skunk Works up there, and I worked in their R&D department when I first started. I was making canoe and kayak paddles. I was the lowest on the ring because we didn't have a janitor, so I was also the janitor at the time. But I worked my way up through the company and became the production manager, floor supervisor, production manager, manager, vice president, president, and then CEO. It took me 30 or 29 years to do that. I am the exception, not the rule. I do not have a college education behind me. I wouldn't suggest that you try to go out and run a company without it. I've had to take classes and go back and do some study, and it was the only skill I have is I'm a mechanic, but I haven't mechanicked in 40 years, so I couldn't even fix a flat tire anymore. So,
to be completely honest, what really made me want to be an engineer was watching the Iron Man movies when they came out. I was like 8, I think, and when the first one came out. And that really got me interested. But as I get older and matured, what I really liked the idea of was making tools. I went to Yavapai for a year, did some basic courses there. Then I went to NAU and finished my engineering degree. 2018, I graduated. Then I decided to move to Iowa, and I worked for John Deere for a year. Decided that the corporate life really wasn't for me. Typed into Indeed engineering jobs near Camp Verde. because I grew up here in Rimrock. And lo and behold, they're looking for a job here in Camp Verde in a manufacturing company I had no idea existed.
Well, before this, I worked at a granite place for 5 years. My wife's grandfather works here. So then once he retired, you know, I kind of got her open a position and I took it.
I've been working for over 50 years. I started working in 1970. I started working before there were computers. I started typing. Invoices used to be on a typewriter. There were not electronic calculators, digital, that you see today when I first started working in 1970. I was very fortunate to get hired by W.L. Gore, which is a very big company in Flagstaff. However, I started out in their Newark, Delaware headquarters. And in 1980, I transferred from Delaware to Flagstaff. That's how I ended up in Arizona. And I worked there as I started as a typist, typing billings, invoices. When I left Gore, I was what they called a plant leader, which is similar to what we call a general manager here. I was responsible for an entire facility as the leader of that facility in Flagstaff. So I retired from Gore in 2000, 2001, somewhere there, and I worked with a fellow by the name of Ken Mall, who lives here in Camp Verde, and he was on Quintus's chairman of the board at the time. He was a board member, and he knew I had left Gore and was retired, and he, I would say, recruited me to come. He saw a need for my financial abilities, my analyst abilities, as far as I do some computer work as well, as far as software, installing software and making sure that it fits for that company. That's kind of a side job as well. And Ken recruited me to come here and work part-time for Quintus.
Well, we're a small company. I mean, we'll range anywhere from, like right now we have about 20 people and we go up to about 70. You know, we're a manufacturing, so we either feast or famine type thing. As the president, of course, you know, I'm responsible for the profit of the company and the stockholders. We're a unique company. We're ESOP, and the employees actually own 51% of the company. And so as you talk to other people, you'll see that most of them have been here 15, 20, 30 years. One guy's almost 50 years. So it's a good place to work. I'm also the production manager because the production manager just gave us notice 2 weeks ago. So my day-to-day is to make sure that the production's going through. I have the personnel in the right place. They're trained properly to do the position that they're in. For ISO 13485 and 9001, so everything we do, we have to say what we do, we have to do what we say. These guys have to do the same thing over and over again. They cannot vary, they cannot change anything. You know, we have certain specs because of the government. And so my responsibility as a production manager, make sure everybody's trained, they're doing their job correctly.
I've worked for the company for 50 years. And so as you can imagine, I've had a lot of hats. I've been mostly doing production type work, production type engineering, coming up with new processes, things of better ways to make things happen. I also currently serve in a regulatory manager position where I'm dealing with OSHA, dealing with the regulations that they have, basically making sure that we are disposing of materials properly, that we are taking safety seriously and working in those capacities. That's probably my main task right now, outside of floor work, like you have me up against the presses right now. We make some large plates with these presses. Because I pretty much invented that process, I'm the guy who typically gets stuck with doing it.
What my job entails is that it's a big range of things. I create fixtures for the technicians for manufacturing purposes to make manufacturing easier. I work with customers to make sure that when we create a new product that they're happy with the new product. It's a kind of a difficult question because of the scope of everything. Even some days I'll work in the shop to help with overflow.
And I pretty much do everything around here from maintenance to building medical products and the military gas tanks. So I do quite a lot over here. Probably this February be 2 years. Yeah.
I always did really well in math. I don't know if you've heard it from accounting kind of people. Numbers are my friend. Numbers are very important and special, and they're meaningful to me. So I like the numbers, but I also like the analytical part of it, being able to understand how the business works, how it functions, so that I can step back as an analyst and say, if you do this, we can be more efficient, we can be more effective, we can cut scrap rates. I can go out and find different vendors that I can buy materials less expensive. All those pieces fit together. So, you know, the math and analytical side I like working with the engineers because I like understanding how things, how we manufacture things, the nuts and bolts of how we make things.
Well, it's a lot easier to go buy something. I mean, we do have a couple of presses that we've, outright bought because it does exactly what we wanted them to do. But normally we'll get a situation where they'll show us something and it has to be molded. So right there you have to make a mold. If it's compression molded, that means you have to have a press to press it, and you have to have the heat, and you have to have the cooling, and you have to all this. And so what happens is it starts like tanks. We have a sump in it, and so we had to design and build a machine that you put the panels in, and this wheel goes around and around and around and works its way in and out, and we put a perfect sump into the honeycomb. Something like that probably took us 8 months to design and to build. I mean, we've got like our rod cutting machine that we do all the rods on and the chamfers. That's a proprietary thing. We never patented it. We never did anything because we don't want people to know how we did it. If you patent it, they can get around it. And same thing with some of our medical products, what we do in-house, and we do a pultrusion, it's called. Same thing, we didn't patent it because people are smart and they can figure a way around it. So a lot of this stuff is proprietary, and I mean, we do have patents under our names, but most of it's proprietary.
I use STEAM in different ways. Science especially is kind of a weird one to do because science sort of incorporates technology, engineering, and math already. So science is already, I feel, already within those other threes, and technology, the same for that matter. But math, I use math all the time, especially early calculus 1 and algebra 2 and algebra 1 are things you use every day. The higher level calculuses, not really so much. They might come up once in a while, but not really all that important to my job. My college professors probably don't want to hear me say that, but it's the truth. And then art is not so much something I use unless you're specifically talking about the creativity part of art. Because when it comes to manufacturing new tools, I need to, form really isn't something I'm too concerned about. Almost never at all. So I really wouldn't consider art something other than just trying to figure out creative solutions, making things ergonomic.
I value the creativity, and certainly if you're involved in the arts, that's all about creativity. You need creativity to dream up a process. Well, you know what? There are a lot of wannabe textbooks. There are a lot of books written on composites and composites engineering. But all of those have to deal with what worked for this one person or this one company at this one point in time. And certainly there are lots of technical magazines out there that all have to do with, well, this worked for this one company in this one point in time. A creative person somehow assimilates all that information and then says that here is my place. This is my focus. This is new. This is different. This is my first creative answer as to how to solve this problem. And then pressures from the customer, pressures from the administration in the company, they come back and say, no, that won't work. And so then he'll find out why it doesn't work and he'll creatively work around that. So I think the creative part of that is vital. And anytime a company squelches creativity to supposedly make a few more bucks, I think they're shooting themselves in the foot.
Probably math, because I mean, we have to be pretty precise with our cuts, building the tanks, and then medically, we have to be pretty much right on, and engineerily too. I mean, we've got a lot of stuff that we could do. Like
the regular employees, the techs, they They don't need an engineering degree. Our techs are, you can't go out, I can't go out and hire a laminator. They're just not around, you know. So we have to train every person we bring in, other than machinists, they're machinists, and engineers are engineers. Everybody else we bring in, we have to train. Just to be a technician, you have to have a good math understanding, because you're mixing resins, very tight tolerances, you know, within 0.5%. And reading, you have to be able to read work instructions, detailed work instructions. And so most of my guys, I can hand work instructions to them. They can read the work instructions. I can go over the process with them, and they'll usually get it first time because they're so cross-trained here. But I'd have to say math and reading are the one thing the regular people have to make their jobs easier here, you know. And it's not trig or anything like that, but I mean, they have to be able to multiply and divide and add and subtract, you know, basic stuff like that.
We need skilled labor, meaning people who can read prints, they can read work instructions. We make products for the medical and military. We have to be very specific on how we make those products, and we sign our name every day that we're following procedures. You know, it's a legally binding document. So we need people that are can read those types of documents, that can follow procedures, that, you know, come to work every day and that fit in. And that's our skilled labor. For the next few years, we'll continue to do some consulting work. Bidding is a very important part of a business. It really what starts the ball rolling, because if you don't quote to your customers correctly, you're not going to make money. That's something that takes time. It's a pretty steep learning curve to do a bid. I will do that and over a year or so train somebody to take over that. So I'll stay involved at least from that level for some time because there's significant bids.
Typically what happens is we have a customer who says, I need this, fill in the blank. And we come up with the process for how to make that thing. And there's a lot of back and forth because sometimes materials that the customer would like is not, or that material is not available. We have to come up with a substitute. Another thing that happens a lot with this is a quotation process where we design the process around, we have a gut feel of what the customer wants price-wise. And we will do our best to meet that customer's expectations with regard to price. So material costs, labor costs, and typically with what we do here, labor costs far outpace material costs. And so we're always looking for ways to make the part better and faster. And so there's a lot of thought that goes into that, a lot of process engineering, a lot of back and forth. Well, we could do this, but this will be better, but, you know, and so there's quite a bit to it. Sometimes it's very quick. Sometimes it's a week. Sometimes it's a year. It just depends on what is happening. For example, the carbon fiber violins that we did a few years ago, that was an ongoing developmental process that spanned at least 3 years. It just took us a while to lock in, and part of it was that we were dealing with a completely new product. The customer himself, as in the violin playing public, really were not sure what they wanted. And so when it's a gray area like that, it becomes more difficult. When the customer is very specific about what they want, then it becomes a lot easier.
Depending on our workload, we may need more engineers, we may need more support people, but our work, because it is a lot of it, 50% of it is military related, depends on what Washington, D.C. does.
One of our medical companies, we were the supplier of the year 5 times. One company, when we were the supplier of the year 5 times, they had 800 plus vendors, and they only invite their top 25 back every year for a symposium. And out of that 25, we won, they did it 10 years in a row, and I won 5 of them. So that's for quality and on-time delivery. So we were known as the one company, we're the first stock to dock. In other words, our stuff came in and they stuck it right on their, they didn't have to inspect them or anything because they knew that the quality was there, and they just stuck it on their shelf and sold them. So that's why people come to us.
Well, you've heard this ka-chunking sound throughout the interview. That's this press that's to my right, your left. It is having to maintain a certain pressure on the plate. We're actually generating over 200 psi on this plate in its cure. And so it's very easy for 200 psi to leak out of the system, and so we have to give it another kick, and that's what you're hearing with that. At the same time that I'm pressing it, I also have these platens that are the very large steel plates that are pressing down on this part, heated to 350 degrees. Wow. So we have a high temperature and a lot of pressure, and so we have to design our tooling to contain and keep safe people who are working around this. Hang on. This plate is 1.25 inches thick. I've made a mark because we're going to be facing this with the machine. But I think it weighs about 45 pounds. Solid carbon fiber epoxy, a very high temperature epoxy that is used for, they're going to be making typically medical parts out of this. They're going to be taking the whole plate and machining parts out of it. And in this case, this is basically half of a larger plate that's going to be 2.5 inches thick when it's all done. So, yeah, that is going to be very heavy. But right now, this is something that I think about before I go lifting it up.
There's a lot of things I wish that I knew that when I came here. But like I said, if you're not willing to put an effort to it or learn something new every day, then, you know, don't even bother trying. That's what I see it. If it's something that you're willing to learn and you want to learn, then I say, you know, go full on and try to learn it. I mean, I've always been the type, you know, as smaller or easy as the job is, I'd rather give it my full potential and make the best quality for it. Because at the end of the day, if whatever happens, you know, to the company or if I get lit off, I would hopefully be one of the first one they call back, because, you know, I like to put out product besides quantity of my work that I do.
I hear it all the time that, you know, if you're somebody who loves math and loves building things, you should go into engineering. For people who can do engineering, there are more beneficial or more profitable career paths, such as being a doctor or being a lawyer. And I've heard a lot of people say that you really gotta love engineering to do engineering. And I'm not really sure if that's true either, because in the corporate world, I just don't see a lot of passion. I mean, I love being an engineer, I do. But I have a hard time telling somebody else who's not me to do it. If you want to be an engineer, especially a manufacturing engineer, similar to me, what you want is you want to have a desire to know how to do a lot of things. You want to be a jack of all trades and not the master of one. Here I get to program Arduinos, I get to program tools in Python and even in Visual Basics in Excel. I get to work with customers, and I get to be a sales engineer. I get to design tools for people. I get to program the laser etcher, and I get to set up and run the pad printer. I get to do all sorts of things here that helps me develop skills that I would not have at the more corporate environment.
I work with economic development at Camp Verde and with other Verde Valley municipalities. We need more, I'm going to call it soft manufacturing, because we're very aware of our Verde River. So we don't want things that are going to put stuff in the air or in our groundwater or in our streams. But we do need more manufacturing, something that we don't rely on with the tourist market, because that goes up and down depending. But manufacturing it stays kind of mostly steady. We have more work one year than the other, but we've been here for 50 years. we're not going anywhere. So yes, we're looking for more work and partnering with companies. I had a conversation, are you familiar with the Provident group that built Verde Ranches and the RV and the car wash? We're working with them to have some kind of intern work program. They need people to work there, and we're limited. So they're very open to some kind of work program through the school system or through the Yavapai College for on-the-job training.
Bio composites and they're already making biofuels for the military. In fact, the containers we make, they put a self-sealing bladder in them, made out of unvulcanized rubber on the inside, and then outside is cured. And so when the projectile goes through the tank and the fuel hits the unvulcanized rubber, it expands and stops the leak. Well, now that the government is really pushing for the biofuels, it doesn't react to the bladder, so the self-sealing bladders won't work in the new tanks. So we're not developing them, but our partners are developing a new urethane bladder that'll do the same thing, only be affected by the biofuels. But that's always in the back. Everybody wants biofuels or bio anything, so. But we're not into that part of it. We're not into developing the epoxies per se. That's a whole nother industry.
I have been wondering this for quite some time, and I think I have a very interesting answer for you on this. First of all, let me give you a little bit of background. I have a master's degree in mathematics. I teach at the local community college. I teach college algebra, and I am wanting to write my own college algebra textbook and teach out of that. So I have a foundation that I think bears some weight to my answer. My answer is that if you want to do well in this job or any job that has a technical nature, learn to read. Did you see the smile go off my face? Learn to read. Because there's so many people, oh yeah, I can read stop signs, I can read school crossing signs, I can do, no, I'm talking about learn to read books. Learn to read, because we have, I'm going to go off camera for just a little bit. We have pages and pages of work instructions that are critical to being followed. And one of our biggest problems in this company, and probably any company has this problem, is that the employees do not read their instructions. It is critical that you learn to read. The other thing that I have to say has to be a part of a person working here, they must have a sense of humor. And I am not joking. You have so many opportunities for failure that if you do not have a sense of humor that will override that failure, you'll quit, you'll give up. So those two things I think are critical to doing well in a business like this or in any technical business. Notice I did not say go get engineering classes. I didn't say mathematics classes. Learn to read and have a sense of humor.
We wanted to be a company where everyone wanted to work. That they said, oh, this is a great place, you can get a job. We wanted to give back to the community, which we have. We give quite a bit of money to charities around here, trying to keep it local, the schools, the library. I would say that's our proudest thing, is we've given back to the community so much. 50
years ago, very hard for me. I could outwork the men that with similar jobs and get paid half as much. Those stories that you heard 30, 40 years ago, they're true. And I'm an example of that. So it really comes from within. If you want to be successful, you most likely will be successful because you will find that place to work that's going to let you shine and thrive. And that's what I was fortunate enough, that if I worked someplace that I wasn't going to be the best version of me, I didn't want to be there. And I was just lucky to work at Gore and work at Quintus and be able to do that. And I really don't care what the individual is, where they come from, male or female. If I see that fire in them, they're going to work for me.
This is my baby. This is something that back in 2005 we started trying to do, and it took a lot of, we probably spent $1 million in the developing of this project. So yeah, this would probably be it. But really, what I'm so happy with this company is that everybody loves each other. Everybody works well together. We have learned that doing the right thing includes getting people on board and working with them, and not being your own agent of change, but working together. I credit my dad for this. He just really wanted to make sure that people knew that they were wanted here, that they could be trusted, and that they could go far if they hung with us. You know, he just was all about that. He's been, in November he'll have been gone 5 years. We still think it just happened yesterday because he was such a part of this.